Hello there, and welcome back. And I do notice that I'm getting a lot of new first-time viewers now, especially on this build. So welcome to my workshop. So I've completed the left and right y-axes, and I'm just putting together now the x-axes. I'll leave the Z for much later. And I've completed the chassis rails, which actually connect, the left and right together, and which form the basis of this CNC router build. And so all the drawings for this build and all the information of parts and specifications will be available on my Patron pages. Now, Patron has actually put something in place because people, not just to my channel, but people were pledging and then being allowed to go into the Patron channel pages and to download whatever they wanted and look whatever they wanted, and when it came to time to pay, they were declining and just going away. So Patron has put a stop to all that right throughout its entire Patron network, so unfortunately we all have to pay the price. And that is that when you join Patron and pledge, you won't be able to have access to things like drawings or much at all until after you've made the first payment. That's the unfortunate thing, so there's some rotten eggs out there, or bad apples. There's some bad apples out there that spoil it for us all. So I must apologise for that, but it's out of my hands. So anyway, so today, because I'm getting so many new people in and asking me so many questions that it's impossible for me to sort of answer everything. I will direct you to look at previous videos, because you will find the answers to a lot of your questions there. But still send questions in, and I will put answers into the new videos. Now I've had several people that are very, very new to metalworking, although they're woodworkers, and they're asking about tapping a thread. Okay, so I'll quickly show you what I do, and I've been doing it for 50 years or more. It's the easiest way I found, especially in aluminium, because although it's soft metal, it can be tricky to put thread in. So we'll do that right now. Oh, and incidentally, during this video too, I plan to do the first part of the build. So we're actually going to get it looking something like a CNC router. We're actually going to bolt some of this all up together, and we'll have a look. We'll see what we got. Cutting or tapping a thread into aluminium. Now this is 10mm aluminium plate, and I've got, okay, this is a 6mm, or for a 6mm bolt, which is here. Okay, that's the 6mm bolt that's going to go in it. Quite small, but it's to hold these bearing blocks in. Okay, and it's what they're already made for. The thread pitch is 1mm. Okay, thread pitch is for every 1 revolution, it's going to move in 1mm. Okay. Now I've drilled a 5mm hole in here, which is about right for this thread, being a 6mm thread. There's about 1/2 millimeter depth of thread, thereabouts. Someone would probably correct me there, saying, oh, it's 10,000 more or something, but it's okay. So what I do, especially in aluminium, is use WD-40, okay, or a very, very light oil, like 3-in-1, something like that, or machine oil, you know, like Singer sewing machine oil, anything like that, fine, light, all right, you don't want to gum it up. So a little bit in the hole, like that, and a little bit on the tap itself. Oop, there we go, just a little bit like that. Now, to start the hole, what you need to do is stand and sight directly over top of the hole. Alright, and put the end of the tap in, and you can look down through alongside the tap, and you want to be vertical. Alright, so the best way to catch all of the tap is with your hands like this, if you can see that, and sight down through, and just make sure that you are vertical, and just a slight downward pressure, about 1 kilo or so, 2.2 pounds, 2.5 pounds in pressure, if you can imagine that, just light pressure, and just turn. Whoop. Turn very slowly, keeping a little bit of pressure, and you'll feel it go a little tighter, and even a little tighter. Okay, so we're trying for 1.5 turns, still keeping it upright because it will move around a bit, but you keep it as steady as you can and as upright as you can. I think that's pretty well 1.5 turns there. We'll call it that. Now turn back about 1/3 of a turn back, and it's loose. Then it'll go tight again. And when it goes tight, what it's doing, the back of the cutter, you can imagine. Here's a cutter. All right, so when you cut in that direction and you turn it clockwise, all right, so the swarf is being cut, or the thread's being cut by this leading edge here. All right, so when you turn him back like that, you're pulling that leading edge off that piece that you've cut, and it's still there hanging onto the inside wall, and then this one turns back on it and cuts it off. So that's what we're doing now. So loose, 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 tight, and you can actually feel it come away. So we go 1, 2, 3. Feel it getting a little tighter. Back, gone tight again, and break it off. And you do that all the way through. It's as simple as that. Go to the cut again, so that's 1, 2, 3 half turns, turn back. See, it goes tight there. One. And if you want to, halfway through the cut, put an extra little bit of WD, or whatever you have. You can tell we're nearly all the way through now. Yeah, very easy now. Yes, that's it. Just cut through 10 millimeters. Okay, so when you assemble this, there's 1, 2, 3, 4, 5 holes set out on the right side and the left side. Okay, now this needs to be at the bottom. Okay, because this is for chassis members. One of the chassis members, and roll it over. Now, all you need is just a fairly good flat surface. Now, I know this bench is pretty damn flat. You know, you don't have to be too sort of, how can I say this? You don't need to be ridiculously sort of accurate. Within 0.5 millimeter of square is fine. You know, this is a CNC router that's going to be carving wood and occasionally aluminium and brass, but it's not a high precision machine like a CNC milling machine where you have to, you know, work within, you know, plus or minus 1 thou. This is plus or minus 10 to 15 thou, because that's okay for these. Alright, so what I'm going to do is set out all of these like this, and we will start to build it. 1, 2, 3, 4. Now this one goes in this way up about this height, actually about there. Okay, to brace everything up together. You know, the work envelope is about 400 millimeters by 400 millimeters. It's about 14 inches square. Okay. Hopefully this is going to go without a hitch. Now what I've done is I've laid these out in the rough vicinity where they should be. Very rough. And I've taken out the bolts that go into the locking mechanism, and we'll offer this up to here. Now hopefully that should be exactly square to that. Now that should line up straight away, hopefully. Now, because I have one in, you know, I won't be holding this up then. Get yourself a set of Allen keys with a rounded Allen key end. It's the first time I've done this, so if I've made any mistakes, you're going to see them. But I don't think I have. Oh, look at that. Pulled up square. Just going firm at the moment. So that's what I wanted to do, just get one in there. Just to, so it stays up itself. Over this way a little bit, I think. them together pretty damn easy actually. And look, I've got two squares here, one on this corner and one on the corner over there, and look, it's within 1/4 of a millimeter, which is what's that, 1/10 in square. I don't think I need to get it any squarer than that. It's fine for what I'm going to be doing anyway. And of course the x-axis, which is this, will fit. Let's get a couple of blocks of wood actually. Well, I'm pretty pleased with that actually. Goes together really easily actually, and like I was explaining just now, it's very square, and you know the work envelope here is actually going to be adjustable. It's going to be 400 by 400 square, but I'm making it in such a way that the side plate over here, I'll come over that side and explain. That the side plate that goes on here, okay, there's going to be an aluminium block here which is on the ball nut, and it attaches to the underside of the riser, or the gantry arm that comes up here. So what I'm going to do is I'm going to have three or four pairs of drillings along it, so I can choose the extent of travel forward. In other words, I've got an old hose in here. I can adjust it, I will be able to adjust it, so the maximum travel in normal position is sort of here, which is about an inch from the very end, okay? But I will have enough adjustment there for about 3 inches, or 75 millimeters. So that means I can bring the actual, adjust it, so I can, if I wish, work over the front here. Because what I intend to do is make box joints, okay? So that means I can attach something, you know, wood, clamp it to the front, this front edge, and I'm going to continue this down. I'm going to build some sort of mounting area then, so I can mount planks onto the face of the bench, of which I'm going to make a new bench for this, and I can write a program in Carveco and I can make box joints very easily, even dovetailed ones. And I'll show you how to do all that. So, you know, so it's 400 millimeters square, but it is further adjustable, that I can bring it on forward by 3.5 inches or 75 millimeters if I wish. Z travel is going to be well, it's actually made for about 150 millimeters. I'm never actually going to use all that, but it's there if I do need to. I'm going to have 2 layers onto this. Now the first layer is going to be a 3/4 inch sheet, possibly MDF, may also be marine ply. Haven't made my mind up yet. And then I'm going to cut strips and rake the back edge out of the ends of them to make T-slot ways in here, which will be sacrificial as well. Instead of a full waste sheet, I'm going to have it so I can, sort of bolt things down, as in T-slot ways, and also be able to screw into the sacrificial sheet as well. So that's going to be 1.5 inches. So I'm going to lose 1.5 inches here. 1.5 inches. How many millimeters is that? Over this side. Oh, about 40 millimeters. Okay. So then I've got, let's see, 40. So I'll be able to get about 4 inches under the gantry. Okay, so something 4 inches high, and machine it. Now I've chose that because I've never actually, well look, I have put thicker things in here, but in my other router, but let's be frank, very unusual for me to do that. And I only did it for demonstration purposes anyway. Most of my carving is less than 400 millimeters wide, and is only a maximum of possibly 3 inches in the Z. It just, I just don't normally machine anything thicker than that. However, you may or may not know, if you've been following this series, I am actually making 2 of these. This is the first one, this is the small one, and I thought I would start with this small one because I actually bought and built and upgraded a 318, or 3018 actually. I did some 17 videos on that. I fully uprated it so you could actually 3D carve on that. I had so many people asking me if I was going to make a larger one that you could really do something with. Well, here it is. But I'm going to make one that is roughly about 1 meter by 1 meter square, or could be a bit bigger than that. Could be 11 or 1200. I haven't really decided yet. I'd like 1200. Sounds nice. 1200 is the width of this table, 4 foot. Sort of work area 4 foot by 4 foot, something like that. But it will be built on similar lines to this. For something of this size, and the ability, the ability of this little router is going to be huge. But I do only have a 800 watt spindle on it, which I could upgrade at a later point in time, but I consider it to be enough for this, and I'm trying to keep the costs down to under $1,000, and that's very, very achievable. And I've even got a controller on order, a new type of controller with a built-in 7-inch screen, and you don't require any computers. It runs on, it has all the features of Mark III, but it's a 5-axis, and not that I'm going to be running 5 axes, maybe 4, but yeah, you know, and I want to try it out. Haven't seen any reports about it. It's an SMC 55NN, and I'm looking forward to that actually. So you know, you don't have to have a computer, you don't have to have a screen. Although it'd be nice to hook a screen up to it. We'll see what we can do. Anyway, we'll call this video done today, and don't forget the plans will eventually be available on Patron, and you know, this channel actually survives because of the patrons. So if you would like to become a patron, you know, please pop along and join up. And thank you for joining me, and please press like and subscribe to the channel. That also helps. And I think the next video we might we'll do a bit of CNC milling, because I've got to make the mounting blocks for the ball nuts to the gantry uprights, and we might even build the gantry and get it moving manually. We're a while off getting it running with the stepper motors, but I'm really pleased. Really pleased. So thank you for joining me, and it's oops. So thank you for joining me, and it's bye for now.